The 29th of April, 2026. A quiet morning at the University of Washington. But inside the labs, history is being written. David Baker's team has just released a landmark review in Nature, a document that signals a definitive turning point for humanity. For decades, the world of science relied on the slow, hit-or-miss process of directed evolution. We were merely tweaking nature's existing blueprints, hoping for a lucky break. But today, that paradigm has finally shifted. We have entered the age of precision engineering. The old ways of trial and error are fading into the past, replaced by a vision of absolute control over the building blocks of life itself. Yang Wei, the lead author of the review, stands before a digital whiteboard, the glow reflecting in his eyes. He draws a single, bold line that separates two eras. On one side, how to design. On the other, what to design. In the early 2000s, tools like Rosetta were our only hope. They used rigid physics equations to force proteins into specific shapes. It was a grueling, manual labor of the mind, like trying to build a modern skyscraper using only a wooden ruler and a basic calculator. We were limited by our own mathematical constraints, struggling to mimic what nature had already perfected over billions of years. Then, the AI revolution struck like lightning. Models like RFdiffusion and ProteinMPNN emerged, acting not just as tools, but as master architects. This is generative AI, applied to the very fabric of biology. These models treat protein design like a fine art. They start with a chaotic cloud of random amino acids, a digital mist of possibilities. Through a process of iterative denoising, they sculpt this chaos, carving out functional structures that have never existed in the natural world. A researcher clicks enter on a terminal, and we watch the screen as a complex protein cage assembles itself, atom by atom, designed specifically to neutralize a deadly virus. This is no longer a theoretical dream. Vaccines designed through these digital gates are already in clinical trials, protecting real lives. But the team is already moving to the next, even greater challenge: molecular machines. We are no longer just building static blocks or frozen sculptures. We are creating dynamic protein switches. Imagine a protein that can sense a single small molecule and, in response, trigger a precise cellular action. Yang Wei points toward a future where proteins interact directly with DNA or even inorganic materials, pushing far past the biological limits of evolution. We are targeting the giants: cancer, Alzheimer's, and the escalating crisis of climate change. These are problems that would take nature millions of years of random mutation to solve. We are now aiming to solve them in a matter of years. The scale of this ambition is breathtaking, turning the impossible into a scheduled milestone. As the session closes, the message to the next generation of scientists is clear and uncompromising. Stop solving problems that are already conquered, they say. Focus your minds on the high-energy barriers of catalysis and the complex nanomachines of tomorrow. Our ancestors relied on the luck of the draw, but for us, the era of accidental discovery is over. The era of intentional design has begun. We are no longer just observers of life. We are its purposeful architects. The future is ours to build, one atom at a time.